We just talked about the two types of reasoning that we're going to cover in this class, the deductive and inductive reasoning. Right now we're going to turn to specific laws for deductive reasoning, and there's actually two of them we're going to cover today. The first one is called the law of detachment. The law of detachment sounds kind of weird when you read it at first, but we're going to go through and explain it. If P implies Q is true, and P is true, then Q must be true. Okay? In order to explain that, let's go back and talk about the truth table for this conditional statement, P implies Q. So before the break, we talked about truth tables. And if we want to make a truth table for a conditional statement, like P implies Q or if P then Q, then we set it up like this. We have our two columns. This represents the first statement. This represents the second statement. This represents the compound statement, the conditional statement. And we want to take into account all the different possibilities of P and Q being either true or false. So we have our four combinations: true, 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 false, false, true, and then false, false. And remember that the conditional statement is only false if I have T going to F. Right? So this is true, this is false, this is true, and this is true. This was like the contract we talked about. So we used Tanner mowing my lawn as an example in period 7. In period 8, we talked about Ella babysitting. But the idea either way is the same. P implies Q is like a contract, right? If the P part's true, then that's like the conditions of the contract being met, and then Q is like following through on that contract. So if Tanner mows my lawn and I pay Tanner, then the contract's valid, everything's good. If Tanner mows my lawn and I don't pay him, right, that's not a good idea. That's not what we want. So then in that case, the conditional statement is false, because Tanner kept his end of the bargain, but I never paid him. If Tanner doesn't mow my lawn, but I pay him, that's fine because there was no contract to begin with. If Tanner doesn't mow my lawn and I don't pay him, again, that's fine because there was no contract in force to begin with. So this is the only way we get a false, is T going to an F with the conditional. Let's go back and look at the law of detachment then. If P implies Q is true, okay, well where is P implies Q true in the truth table? Right here, and right here. Right? This is the only time where it's not true. Okay, so if P implies Q is true, right, that we're in one of these three options, true, true, true. And P is true, right? Okay, well, if P implies Q is true, those are three options. Of those three options, we're going to say P is true. That eliminates this and this and this. Then again, the only option is that Q is true. So we're like, if this is true and this is true, then this has to be true. It's kind of like looking at that truth table, okay? So when you're looking at a statement like a detachment, a statement that uses the law of detachment as like a reasoning, the format is going to be, you're going to see some general statement, some generic statement, and then you're going to see a specific example of P being true, and then the conclusion is going to be in that specific example that Q is true, okay? So it starts out general and it goes to specific, just like we talked about with deductive reasoning, right? General to specific. So this is more of a general statement right here. And then we're going to get a specific P and a specific Q. So this is an example of that, right? If the measures of two angles add to 90 degrees and the angles are complementary. Okay, that's just like a generic P implies Q, right? There's a P implies Q here, and we know that that's true. Okay, the next statement here that we see is an example of P being true, right? If we look at this first statement, the measures of two angles add to 90, this part right here is P, and then this part right here would be Q. Actually, let me underline it differently, make it wavy. Okay, that's the P implies Q, right? If P then Q, it's a conditional statement. The very next statement after that first statement is a specific example of P being true. So I'm going to do specific example of P. So what has to happen is that in that specific example, Q has to be true for that specific example, right? So if the measure of angle 1 and the measure of angle 2 equal 90 degrees, okay, that's a specific example of P being true, then in that case, Q has to be true. Angle 1 and angle 2 have to be complementary. right? So it's a Q, but it's specific to these angles. So this right here is our specific example of Q. Okay? That's the law of detachment. We start with a general conditional statement, and we already know that this is true, like we've established that's true. And then we throw a specific example at you, and then we kind of bring it all together, right? That's the law of detachment. So on your homework, you're going to see more examples of that. You're going to practice. But that's the law of detachment, and it basically just comes from this part of the conditional truth table. If P implies Q is true, there's 3 options there, and P is true, okay, now there's only one option. The only option is that Q has to be true. And again, it goes from general to specific.